So today I'm going to show you how application load balancing and monitoring can be deployed in just a few minutes and made really easy using Kemp Technologies. Delivering a proactively monitored always-on application doesn't have to be hard and can be done in just a few steps. So I start off with a single application delivered by a single server that users are accessing directly. So here's my sample application, which at the moment is loading pretty quickly. It takes about 200 milliseconds. So imagine we get a sudden surge in connections to that application. Perhaps there's more people accessing the application remotely or something like that. And now maybe we have something like the following. So you can see the page is much slower to load, still loading but much slower and potentially negatively affecting the user's application experience. Or even worse than that, perhaps the server may be getting so many connections that it cannot serve them all, and potentially we could have a situation where users are getting no response. You can see here the browser is trying to load the page, but unfortunately the site can't be reached. So what I've shown is an application that was running, now unavailable to users. In order to address this, I navigate to kemp.ix, and here I can download a trial virtual LoadMaster, which is the Kemp Technologies load balancer. Now you can see here the first step will involve creating a Kemp ID. In my case, I've already created one. So what I'm going to do is log in with this. Creating a Kemp ID is really quick, involves filling in some details and just verifying your email address. So once logged in, the next step is to select my hypervisor. In my case it's VMware, and then my country, which in my case is Ireland, and then you need to hit download. So that's now downloaded. I'll navigate to the file location and I need to extract it. It's a zip file, and then within that directory you have some documentation and also an OVF file, so I'll extract that also. And now I can go to my hypervisor and deploy it. So I select deploy OVF template and point to the files that I just extracted. Then I follow the on-screen directions. So for all hypervisors supported, your download will include a guide, or you can refer to the Kemp Technologies documentation site. So now I've deployed the LoadMaster and turned it on, I can set it up. So from the console menu, I log in with the default BAL user. And I use the default password, which is one for all. And now I'm going to configure it with the IP addresses. You can use DHCP, but I'm using static IP addresses. I set the default gateway, and then the DNS server I'm going to use. And if required, you can set a proxy. So this is really only used when you're licensing the device. In my case, my LoadMaster will be able to connect out, so I don't need to do this. And now you can see, to continue licensing, I can access the LoadMaster directly from its web user interface. So I hit proceed. And now once I agree to the end user product licensing agreement, I should now be able to license. So I do this using my Kemp ID and password. And I'm going to select a temporary license, which by default is the VLM Max. You can see here I have a license for 1 month. And next I'm going to set the password on the device. And then I log in. Okay, so on the initial LoadMaster menu I have a couple of options. I'm going to configure a simple virtual service. A virtual service is an application endpoint I create which distributes and load balances traffic amongst one or more servers. So I'm going to give it an address. And I'll give it a name. And now I'm going to add the real server to point to the application server I've been using. In our case, the server has since restored, and I input the IP address as the real server. Okay, so now I have a virtual service set up and at this address here, and you can see that I've just one real server. So in order to test this, if I access the virtual service address directly, you can see I can access my application. So now I haven't really done much yet because I still only have a single real server, but since it's now configured as a virtual service, I can add multiple real servers and then point my traffic to this virtual IP address to distribute and load balance connections across those real servers. So now I'm going to spin up another real server. The way I'll do it is by cloning my virtual machine. And then after cloning the virtual machine, I spin it up, configure it with a new IP address. Then I move it to the correct network, power it on, and this then gives me a second server that I can use to deliver my application. So now I should be able to access a second instance of this application. I'll just give it a minute to boot. So you can see I now have a second instance of the application running. So to recap, at the moment I have two real servers. I've added 225, which is the one I've added to the virtual service, and I've 226, which I'll now add to the virtual service, which will point to my new application instance. Okay, so you'll notice I now have 226 and 225. And you can see them both there. So in order to direct all my traffic to the virtual service, I'm just going to update my domain name to point to the virtual service IP. So now if I go to the URL, it should hit the virtual service. And just to confirm that, if I look at the statistics, I should see connections. So here I have some connections now going through the virtual service. So just to summarize, I now have a virtual service configured with two real servers attached to it and traffic now load balanced across it. So that's all great, but let's see what happens if one of the servers fails. So at the moment, just to recap, we have 225 and we have 226, which are both currently running fine. So what I'm going to do is show what happens if 225 fails again. So you can see 225 is now unreachable. and you can see from the virtual service status indicators that 225 has been marked down. However, if I access my application, because I have a second server configured, access should still be fine. And if we look at the LoadMaster statistics, we should see all connections going to the second server. So 226 is now handling all the connections as a result of 225 being down. So this illustrates that with our virtual service in and one of our servers down, our users can still access the application. So let's now bring the server back. So now you'll observe that 225 is available again. And you can see our virtual service has updated to include 225. And now looking at the statistics, you can see connections are now back to being distributed between the two servers. So, now that we have our application load balance, we greatly reduce the risk of downtime. However, it doesn't stop there. So Kemp Technologies also offers a monitoring service specifically designed to identify risks and notify you of potential issues to your application delivery. And this is just as simple to set up as the LoadMaster. So what I'm going to do is go to vision.kemptechnologies.com, and here I can log in with my Kemp ID and password, just like before. Okay, so on login, the first thing we're asked to do here is connect an agent. So just to explain, a Vision agent is a device we deploy in our network to monitor our application delivery, detect issues, and notify us so that we can take proactive action. So I'm going to assign the agent a name, in my case LIMDC for Limerick Data Center, and then I'll assign it an IP address. And for the hypervisor, in my case I'm using VMware. So it takes about a minute or two to build the Vision agent. It's a bespoke virtual machine, so it'll have the IP address that you added configured on it. And then once it's turned on, all you really need to do is deploy it in your hypervisor. So just power it on, and it should connect back to the Kemp cloud infrastructure for handling notifications. So you may need to double check that the required uplink from the Vision agent to the Kemp infrastructure is permitted. And you can see in the diagram that the IP addresses and ports it'll connect on are provided. Okay, great. So the agent has been created and configured. So now I just need to download it. Okay, so that's downloaded now. So I'm going to extract the files. And then I'm going to go back to my hypervisor. And I'll select Deploy OVF Template. And then I deploy the Vision agent through my hypervisor, just as we did with the LoadMaster. Okay, so now I'm ready to power on my virtual machine. And as I'm doing that, I return to the Vision screen. So you can see that Vision is currently waiting for the agent to connect back. And once powered on, the agent has started and is running correctly and connected. If I hit continue, the next thing I need to do is add a communications channel. So this will allow me to receive notifications from Vision and enable me to take proactive steps when Vision detects a potential issue with my application delivery. So I select add new channel. We can use Slack, email or SMS. For this example, I'm going to set up an email channel. So shortly after adding that, I get an email asking me to verify my email address. So I'll do just that. And now my communications channel has been successfully created. Okay, so you can see now on the screen, the next thing I need to do is add a cluster. So this would typically be a single or pair of LoadMasters. I click add. And all I need to do here is put in a name for my cluster. I'm going to call it production and then the IP address. So which in my case is the IP address of the LoadMaster I just deployed. So after that I need to put in the BAL password. So this allows the Vision agent to be able to connect to the LoadMaster and gather the metrics and states it needs to detect any issues that need to be addressed in order to ensure the application experience is maintained. Okay, so now I've added the cluster and everything looks good. So let's take a look at this in action. So here you see 225 is down again and it's marked as failed for the virtual service. Now obviously our application is still operating because it's load balanced, and you can see all the connections are going to 226 now. So here you see the notification from Vision. So the real server is unavailable, and it tells us that the app is still available, but connections will no longer be sent to the real server with 225 address. So you can see it provides some relevant information about the last time the server was down, and also details of whether there were any recent configuration changes that could be relevant. Always a useful thing to know. So to recap again, we've seen one of the load balanced virtual service real servers failing, and Vision detecting this and notifying us of the failure along with the details we need to address the issue. So now let's bring the server back up. So perhaps after receiving the notification we proactively fix the issue and as a result prevent any adverse effects on our users. So you'll also notice that Vision will email us when our issue is resolved and give us context around the resolution, so for example if connections are restored to an application and so on. So we saw a very simple example of Vision in action. Vision will also notify you of a wide range of potential issues to your application delivery. It'll notify you of any servers that are down or even up but slow in handling requests. It'll notify you of any issues on the LoadMaster itself related to system performance. So for example, if you have high CPU or memory usage as a result of high traffic loads, it'll warn you. It'll also alert you to maybe traffic levels that are much higher than expected. It'll notify you of issues with licensing or even firmware versions. And it'll even notify you of security events or certificate issues that need to be addressed. So I think we've illustrated the benefits of application load balancing as well as monitoring of application delivery. But most of all, I think we've shown how easy it is to set up, particularly using Kemp LoadMaster and Kemp 360 Vision.